As I mentioned to some of you during the reading group before this conference, I will be using the idea of correspondence and representational mechanisms to comment on some of the Mark Vicker's work. So here's how I will proceed. Here's my roadmap for today. I will start from some remarks on semantic information and representing. That is important because some people thought that my notion of semantic information may be unconstrained and not sufficiently clear to allow for understanding what's the vision behind it. So I will present the vision behind it and say how it is similar and how it is different from what Mark has offered, and that will allow me also to comment on his overall interesting and extremely inspiring notion of representation. So I will introduce the notion of a representational mechanism, its features. Then I will go to discuss operations and vehicles. You will see that it touches upon some of the themes that occur in the polemic with Paweł Wojciechowski's account of representation as present in a paper by Mark Pickard and August Sardin. Then I will discuss some of the issues related to normativity of representation as related to having and serving functions. And then I will talk some on levels of representationality by claiming that levels is possibly not the best metaphor to talk about. Okay, so let's go straight ahead. So our task for today is to understand how representing is related to semantic information. And semantic information, I understand broadly as simply as semantic information is information which is about something. About something in virtue of what? In virtue of whatever can undergird the natural significance relations, which usually are thought to occur whenever you have a relation of similarity or correspondence, as I dub it. So in my correspondence theory of semantic information, I rely on similarity, and you could also rely on probabilistic notions or causal notions. So that is the majority of work on natural semantic information, which can be found in such accounts as Dretski's, Millikan's, or Shea's. Isaac links similarity with correspondence in a certain interesting way, but I will have little time to discuss this. That's not essential here. I'm a pluralist about semantic information, so I think there are lots of possible constituting relations that could undergird semantic properties of pieces of information. And my claim is that representing implies that there are vehicles of semantic information about something. That does not mean that representing is reducible to there being vehicles of semantic information. Semantic information can be out there without any agents or observers to see that, but it still be undergirded by certain objectively accountable relations. So what was the gist of my correspondence theory of information? So by correspondence, I understand structural similarity between structures. And the most general account of similarity can be proposed, I believe, by adopting a generalized notion of infomorphism as introduced by Barwise and Seligman in their influential book on information flow. And I generalized that notion to talk about info correspondence, which is a relaxed notion of infomorphism. So basically, the idea here is to think of information transfer as relying on correspondence and vice versa. And then you can see that notions that are used to talk about information transfer or information flow can be used to describe what is going on when you have semantic contents constituting relations. This is because it is logically impossible for information to be transferred without any correspondence whatsoever. So it is not a coincidence that those things go together because they are logically connected. Moreover, I would stress that information transfer and correspondence are conditions for reliable aboutness of information. My account is so relaxed and liberal that it allows for cases of serendipitous models, things that turn out to be models without there actually being any reliable transfer. That can occur and sometimes happens. So we need a way that it's like an objet trouvé. So we find an object and it turns out that for some random fluke, it could be used as a model of something else. That is, however, not the most reliable way of actually thinking about semantic information and using semantic information. So let me just briefly introduce the notion of infomorphism here. Infomorphism is a pair of functions, f with a caret and f with a dash, downstream or down caret. So we have two classifications which are consist of a certain number, certain types and certain tokens, and a relation between those types and tokens. So we have a certain way of classifying tokens into types with a certain binary relation sigma a. Those things are not really very important for us. The important thing is that we have tokens and types that correspond to each other, and we have one way of going from one and one going from another. So we have some tokens A of A and or tokens B of B that correspond to one another, and that's the important thing. So we can go from one classification to another classification. Some have insisted that this is something like predication already. That is quasi-predication, I would say. Similarly, as you have in Dretski's account of natural information, certain property of an object indicates another property of another object. So it could be used as ascribing features to an object. Dretski's notion of indication, however, goes deeper because it allows you not only to classify things as belonging to certain types, but also it allows you to bring it into a predicate object structure. Here we don't have anything like that. We have just classification, so a yes-no question, which is more basic than that. But we can go beyond that. We can build more complex structures that involve something like predication if we simply have more classification built on top of one another. We can model that, but it will require a little bit more. So the basic building block is just the classification in Barwise and Seligman sense. Now, how I relax this? I relax this in a very simple way. So basically, I don't require all classifications to correspond to one another. So at least some tokens and some types are required to correspond to one another. That's a huge relaxation. And classification need not happen as subsuming into a type in a set theoretical binary yes-no fashion. It could be subsumed in a fuzzy fashion if you go for fuzzy set theory. Simply a token may be a member of a set to a certain degree, just in Zadek's account of fuzzy set theory. So that's a very relaxed notion. That is not very usable in itself, not very usable per se, because we usually want to have a more particular kind of structural similarity in play when we want to talk about correspondence-based semantic information. The reason for introducing this is that I want to account for all possible varieties of similarity, and there are different, really various measures of similarity out there. So that is the reason for going so general and being so liberal, so that you could have a more precise, more constrained notion of a measure of similarity that could produce also a measure of semantic information if you go from that. But in general, it is left liberal so that we could go for various kinds of correspondence for semantic information. And now let's connect this piece, semantic information, with representational mechanisms. I think that cognitive systems, cognitive agents in general, and cognitive systems which could involve more than just one agent are able to represent as long as they have representational mechanisms. Mechanisms, I understand, just like all defenders of new mechanism, such as Bill Bechtel, Karl Praver, or Stuart Glennon. These are complex functional structures that involve organized components that interact with each other. So there are some interactions, some operations of these components, and that interaction contributes jointly to a function of the complex whole. So they are always mechanisms of something, and that is their point. This is basically a very epistemological notion of a mechanism. It is not any notion that is deeply ontological, so it's epistemology first. So we first have to specify the phenomenon we are interested in explaining, and then we posit a mechanism. So it's not that there is a mechanism whose function we do not know. No, first we have to understand what is the phenomenon that we're looking for a mechanism for. So that's the thing. It's not a physical system, rather is the causal structure responsible for a certain phenomenon that occurs out there. Now, here comes a very controversial part. I think that these representational mechanisms are computational in nature. Although I believe that computation is just a necessary but not a sufficient condition of representation. So I have Fodor's slogan backwards. Not that there is no computation without representation. Instead, there is no representation without computation. Representation is much more restricted a notion than computation in my account. By computation, of course, I mean whatever is understood by computation by new mechanists, such as myself or Gualtiero Piccinini. So, what is required? Well, if and only if a particular kind of computational mechanism is recruited in the adaptive control of behavior as related to the semantic information processed in the mechanism, this mechanism acquires representational function. But that is not exactly sufficient. We need to have certain features of that computational mechanism more precisely specified. If we can find these features, and I will specify a schema for these computational mechanisms that can serve as representational ones in a minute. And if that thing which has these features is recruited in the adaptive control of behavior, and that recruitment is not, in my opinion, anything which is supererogatory. I think it's obligatory because of the notion of adaptive control of information. That's a conceptual link. And now here comes, I believe, the most controversial part in this presentation today. Namely, the surprising consequence of my account here is that if you follow my understanding of the basic terms such as the mechanism, representational, computational, and so on, then interactivism is also a version of mechanism and one that is committed to a certain version of computationalism. That is a very surprising consequence because you might think that there is nothing that could be more distance from interactivism than computationalism. But it is not the case because my account of computation is not symbolic. It is not committed to symbols in a traditional sense. It is mechanistic. It is mostly physical. That's what counts. And we'll see that those conditions are they present us with a fairly low bar. But that low bar is what is actually in place when you look at how people use the notion, those who are committed to computation, who defend computation, from Newell and Simon to Chris Elias-Smith to Barbara Webb to Jay McClelland. Now, let me now go to features of representational mechanisms. To explain the mechanism is to explain its capacity or function. That is one of the trivial claims of mechanism. So what are these capacities that we should be looking for, in particular in these computational mechanisms that we want to evaluate as possible candidates for representational mechanisms? So they should have at least three functions: referring to the target, if there is any target of the representation. Here, aboutness comes in, identifying the characteristics of the target. You could call it modes of presentation, and evaluating the epistemic value about the target. Let me discuss them in a little more detail. So the first two are part of the standard framework, from Frege to Kazimierz Twardowski, through Ruth Millikan, through Rob Cummins to Tyler Birch. Of course, there might be differences in how people think of modes of presentation. Some people might want to deflate them. I believe in teleosemantics, you could understand mappings between, for example, bee dances and nectar as specifying something like a mode of presentation, just in the correspondence theory of semantic information. I think this is exactly the same idea. So my notion of characteristics is pretty easy. So as far as you can find any structural correspondence, you find something like a mode of presentation, because that structure is specified by some classification. So you already know at least some features, not only the referent. It's not only the causal thing. It's not only a probabilistic thing that you might be interested in. It is also, and most of the time predominantly so, connected to how things correspond to one another, to how classifications correspond to one another. But the third feature is more surprising and is heavily inspired by Mark Bickhart's take on representation. And I also think that is implicit in lots of cognitive psychology and cognitive science, because that is the epistemic value of representation. Without it, it would be just hard to justify why behavior of the system would really need to depend on representation. That is the core of the adaptive, evolutionarily important value of representation. That is what contributes to stabilizing representational mechanisms in the evolutionary history of agents, biological agents. And one particular feature here is error detection. I don't think it's the only important feature. So detecting error is one part. You might want to account also for stabilizing and adapting the characteristics of targets over time, as Cameron Buechner does in his recent forward-looking theory of content forthcoming in Ergo. You could also be interested in lots of other epistemic operations here. I think this is where representation actually comes close to epistemic virtues, to epistemic values. And there might be different ones. And depending on the epistemological needs and context, agents or systems might be prioritizing one virtue over another and discarding some vices as irrelevant, or stressing the need to actually avoid some vices. But that's a side issue. So I will focus here on error detection because it's particularly relevant. Unless there is error detection, system detectable error, you cannot talk about representation. This is not one of the conditions on semantic information that I have. And here also I agree with Bickhart's interactivism that semantic information can be called differentiation. It is not yet cognitively relevant unless it has certain role in the mechanism. The role of the cognitive machinery has to be able to account for errors. For example, to enable learning. But in this account that I will defend here shortly, it relies on incoherence detection rather than only on unfulfilled presuppositions of actions performed. And there is a reason for that I want to expand a little bit. So what's the problem with the action-oriented system detectable error, the standard account of interactivism? As Krystyna Bielecka in her book, which is unfortunately available only in Polish, that's a reworked version of her PhD thesis, she argues that there could be no error in a representation even if action fails. So she uses a dummy example of a frog. She has a motor plan. She wants to swallow a flying fly nearby, but a meteor hits the earth, killing both the frog and its prey. The action obviously is unsuccessful, but the frog frog's representation is not to blame for the failure of action. The meteor might also not kill the frog. Still, the frog is not to blame. She is not able to represent meteors. That would be biologically unrealistic. You could have everything fine in place, but there might be problems in simply executing your model plan that are totally unrelated to whatever you could do. The world can fail us in multiple ways. So the connection between the failure of action and the failure of representation is not a conceptual one. There might be a wedge between them. If there is a wedge, then the notion of making it a fully pragmatic issue is doomed to fail. It's doomed to failure for a very simple reason. Simply, it is overly optimistic in thinking that failure of actions will translate into our knowledge of truth and falsity. Analogically, and that's fairly obvious, the action could be successful even if it relies on false presuppositions. We know lots of that. Nocebo-placebo effects are based on false presuppositions. So there might be things going on because you think about something falsely, and you can achieve your goals based on false presuppositions. You might never detect your error this way. And you might say, of course, but the agent would know that it's an error. Well, sometimes it could discover that, but the effect would be already in place. So what do we do? There are two ways out. The first way out is fairly simple. I suggested that way a little bit earlier, anticipating possible arguments against this pragmatic take on truth by trying to make action to mean any cognitive operation as well. So that stretches the notion of action. So whenever you can have any action, even in thought of an agent, that seems to fail with certain representation, then you could say, well, it failed also in your thought. You were able to do something about it. And the agent might discover it was an error after some point. It just depends. These are actions as good as any other action. That was a move that I recommended in my book explaining the computational mind in 2013. I'm not sure if it's the best move because this notion of action is really diluted, and it's not really quite clear how the failure of action is actually available to the system. How exactly are you able to evaluate the failure? How do you know you failed? You had some expectations and so on, but in what form do these expectations come? You might say implicit expectations. Yeah, sure, but what do you do with them exactly? Show me the algorithm. And for these considerations, I started to believe that Bielecka's account is much more realistic because it actually subsumes action-oriented system detectability error. So her proposal is to make clear that the best proxy naturalistic approaches to representations may have for falsity is simply any kind of incoherence. And that incoherence includes the incoherence between explicit representation and implicit presuppositions you might have. You need not compare full-blown representations. It's enough that you compare semantic information, which is not user evaluable, not available to the agent, but it is still out there. It's incoherent. It plays some evaluative role, but it's not evaluated by itself. So it does not go into this vicious circle that evaluating a representation requires yet another representation which still has to be evaluated, and that has to be evaluated. That would be a vicious circle. We don't need that. We need only semantic information. We only need tokens that would be different from other tokens. Those tokens could simply come from classifications that are out there in a nervous system or a computational system, whatever you want to have as realizer of those representational mechanisms. So basically, that includes implicit presuppositions and explicit representations, but it is not limited to that way. So that subsumes the pragmatic notion, but it opens up a space for a more straightforward treatment of various other epistemic actions, epistemic operations the system may have. Still, it is very close to the considerations cited by interactivism. Now, let's go to yet another important feature of representation mechanisms: vehicles and operations. Talk of representation is hollow unless, first, representations have observable physical vehicles. These vehicles can be operated upon, especially in valid inferences as observed at least as far as Sloman's 1970 paper, which has been then rephrased and incorporated into his computer revolution book. So we need to have some operations on signs, on vehicles of representations, to actually say that signs are used. That's a semiotic trivial observation. Without it, these are just inert things that do not do anything. They are not usable for any purpose. That actually implies that semantic information, or to use interactivist lingo, differentiation is just a necessary ingredient for representing. And representing could be understood in a processual manner. So these physical vehicles could be spikes. There is little sense to talk about spikes in non-processual way. In principle, observable does not have to be anything that stays the same over longer stretches of time. Could be actually changes that are important. So if you go to the way mechanists think about mechanisms, the standard notion is that it makes little sense to introduce components without specifying the operation. Some mechanists such as Peter Mackamer even go to as far as to say that actually those components are idealizations. These are abstract notions of components. We actually have only operations out there, so he's more processual. There are some other mechanisms such as Gualtiero Piccinini who would say, well, these operations could be thought as capacities, as dispositional properties of those components. I believe those debates are very difficult to settle. I won't settle the ontology of mechanism here, but the standard notion is that we need both in components and operations, and this is what actually fits my picture here. So in the interactivist lingo, there are no representations without the representing, so we need some operations on them. So something has to happen with them. If we don't know what happens with them, we are actually playing with a very, very unspecific notion of representation. This is more like a wildcard notion rather than any specific schema of a mechanism. Now, vehicles should not be understood as passive entities, as I mentioned. These are plausibly processes. And the dynamics of these vehicles can be understood in terms of operations of information processing if there is a structurally valid computational model of this dynamics. And now, here the explication of why interactivism is actually computationalist. The surprise becomes a little smaller if you understand that the notion of dynamics here, of operations of information processing, is as broad as to encompass hypertuning computation, Turing computation, analog computation, hybrid computation, memory computation, what have you, including, of course, any evolution operators you could have in your dynamic system. As long as you have a model that specifies inputs and outputs to the system, and these things usually go under a name of a model of computation in the computer science theories of computation. So this notion is not anything new. This notion is actually what is, I think, the de facto understanding of what computation is in computer science. In theoretical computer science, if you take a pluralist view that there is analog computation, that there is Turing computation, and there may be at least a theoretical possibility of hyper-Turing computation, hybrid computation, whatever. I'm adopting a stance that Ron Priestley called transparent computationalism, which does not promulgate the notion of computation from the philosophical armchair. I'm simply saying this is the use you have in the mathematical theory of computation nowadays. It's pluralist. So we have to be pluralist as to allow lots of models of computation if you want to play with Markov algorithms. Okay, if you want to have Kolmogorov-Uspaskich's machines, of course you can, because they still specify certain dynamics of operations on vehicles of information. You could call these rules as well. That's irrelevant to the issue how you call them. The important thing is that dynamics is specified. Now, interactivism has a specific feature. It requires that representing serves a function in maintaining the far from equilibrium state of an agent. This is where normativity of representation is supposed to come from. Now, my brand of representational mechanism does not require that because of an alternative view on a function. I defended a pluralist view that presses that all four Tinbergen's questions about causes of behavior and explanation of behavior are actually functional questions that shed light on different features of behavior. And these do not screen one each other out. Biology needs evolutionary theory and developmental story, and current mechanisms, and current adaptive utility. All these are important, even though these are not independent, entirely independent dimensions. These are still different dimensions that do not screen one another. For computational mechanisms, I understood function in a somewhat less demanding version. I do not think that contents has to have relies on a very simplistic notion of function. But for computational mechanisms, I think what is simply required is that there is a certain blueprint or design that a certain process uses to get certain tokens to be organized according to their types to get a certain organization going. This is a certain modern history notion of function, as you could call it. Ulrich Krauss' account of biological function works nicely both for biological mechanisms as well as for artifacts. That's why I adopted that, because it actually does not present me with lots of problems. I think it actually allows you to avoid lots of problems that people had with both simply Cummins' notion of function and biological notion of function that we'll here defend. But I think that if you want to talk about something a little bit more complex than computation, I think representation is more complex. You need to rely on a much richer view of function. So if you would go for some paper on Tinbergen, current paper such as Lalan's or Strelnis, that I actually took this picture from, you would have both talk of current causal structure, so how is this mechanism constituted, about current utility of this, so that would be also important, so the proximal utility, but also you would want to talk about evolutionary utility of the evolutionary history, so something that etiological function was mostly interested in, so that is important, but also developmental story might be important. As I stretched in my view of mechanism of computation, I only focused on some version of development that was relevant to me. Now, why do I go for this? For this 4 dimensions, at least, in my notion of function of content. Well, not only just to say why I'm not impressed with the argument that the swamp man is not a realistic possibility and that the proper function does not have to answer that question, that there is no problem of epiphenomenal contents because these things do not screen each other normally. They simply answer somewhat different questions about the mechanism, and these questions are important questions that we want to have answered if we want to understand behavior. But also that there is a certain evolutionarily and conceptual argument that can tell you that there is something important about computation and behavior that links all these together. This is the good regulator theorem, as you might have guessed from the picture. So I believe that those representational mechanisms are forced by evolution to be present in any adaptive control system. A good regulator theorem, of course, published in 1970, but that thought was present in Ashby's thinking quite long time ago. The idea is that the regulator has the internal model of the system being regulated. So that means that no complex adaptive control could avoid semantic information And most of that requires representation to keep the model reasonable. So of course, you could have a model that has only semantic information, but if you want to keep the semantic information reliable, if you want to keep the information useful for control, you have to change that information over time. You have to update it in face of new information. So you have to detect error and you have to evaluate the epistemic value. That's the point of most schemes of regulation. How it goes through, whether it's forward-based regulation, whether it's negative feedback-based or whatever, depends on the system. But most complex control systems that we know will require representation to exist. So one caveat, of course, GRT is about optimal regulators. Cognition need not be optimal. Evolution obviously requires only that they be satisfactory, that they will be satisficing. Simply, you have to deal with your circumstances sufficiently well as to reproduce. That's only the thing that is required. So you can treat this as something which is a conceptual constraint on your thinking rather than a physical law or anything. It's just optimality. Considerations are important for evolution. It need not be fully optimal, but it can have heuristic value. So if a certain agent deals with some domain by distinguishing some degrees of freedom in that domain, say n numbers of degrees of freedom, for example, if you have a tumbling bacterium, you could think that it could be simplified as saying sugar, no sugar. Of course, it understands gradients, so there are more degrees of freedom. Then the agent's representation, if that agent is using that and updating its information, for tumbling bacterium, probably not. Probably semantic information is sufficient to track simple magnitude. But if you have more complex control, then you will have agent's representation of a minimal capacity of n bits. That's a heuristic. Bits in terms of structural information or logon in Gabor's sense. And now you can go for something that I call an adaptation of a no miracles argument. No successful action without truth. So, how it goes. Systematic successful action without truth amounts to miracles happening systematically. This is an adoption of a no miracles argument. So if you compare this with our work on structure representations and truth, you will see that it is correspondence, not the structure of a representational vehicle that explains successful or wrong action best. It is the relation rather than just the physical structure. The physical structure might have nothing to do with this unless we can show that this structure corresponds to something. And now, of course, if you can intervene on these things and change the level of success, entity realism will be forced about those representational mechanisms. And this point actually converges with what Thompson and Piccinini says. So what I'm presenting here is an evolutionary argument that has a very specific notion, a function that is very pluralist and much broader than interactivism's. Now let me go to levels of representationality. I will talk about hierarchies here. The usual way people talk about representation is to frame it in terms of levels or tiers. I'm not sure if it's really helpful. So you might talk about personal level, like folk psychological ascriptions of beliefs, desires, and you can talk about subpersonal states, which is the favorite of recent work in teleosemantics and representational mechanisms as well. I'm a little bit guilty of using the term subpersonal sometimes. But how are these two related? That is a worry that some people have, some neuroscientists as well. You could solve that question in at least two ways. You could assume a scale-free model. For example, producers and consumers all the way down and all the way up. No matter what scale of or level or whatever you call it, you have still the same structure. Or you could differentiate neurocognitive, mental, and external representations in different ways, of course. Some might even posit that there is a one-to-one correspondence that Dan Dennett called some time ago a triumphant cascade. I'm not sure if I believe in triumphant cascade. Let me explain a little bit more. So I would bet on scale-free representational mechanisms. Representational mechanisms, the way I posited them, do not have one physical implementation. What I presented is a schema, a certain of constraints that should be fulfilled by multiple mechanisms to count as representational. So this is just a specification of what would be required to classify some mechanism as representational. That is not sufficient, of course, to specify a given mechanism, which is some concrete causal structure. So I would assume that there would be various producer-consumer mechanisms involved on multiple spatiotemporal scales in different networks that could be analyzed together, with the same basic notion used in different ways, probably. And that is in contrast to radical enactivism's stipulation of basic minds without content. Those basic minds would have no content, only the personal level external representations would be contentful, sometimes internalized. But as Tomasz Korbach has shown some time ago in 2019, there are no basic minds if you follow closely the argument of radical enactivism, so it's not a very convincing argument anyway, but you have one notion, so you have this personal level without subpersonal level. You might have some eliminativists who would say, no, really, those folk notions, no beliefs, desires, we have just vectors in a neural network. Or you could have interactivism rejecting external representations altogether. Language is not a representational system. It is just an operator on internal mental representations. I'm not sure if that is convincing. Let me say why a little bit. Let me go to my joint work with Mateusz Chochol, who's a specialist in geometric cognition. I'm not, but we have worked a little bit on geometric artifacts, cognitive artifacts in traditional Greek geometry. So if you want to understand the proof in Euclidean geometry, for example, the construction of equilateral triangle ABC here, we need not only hardwired core cognitive capacities that we share with lots of animals that are cognizant of their geometry in their environment. Lots of animals have geometrical capacities. They sometimes are surprisingly good at doing so, including insects, as Mateusz has shown, Mateusz Chochol. But we need something more, which is crucial to our understanding of geometry. These are diagrams, so you need to see the circles, see the triangle, but you also need symbols. Without A, B, C, D, of course these could be Greek letters as well, you will not be able to perform proofs. That is crucial. And you need a technical variant of natural language, of course, in the original Greek. There was a very restricted vocabulary, as Raviel Netz has shown. That is a very specific variant of Greek that is formulaic, and that formulaicity, that character allows people to draw inferences over and over again. But that language is insufficient to prove lots of theorems in Euclidean geometry. You need to consult the diagram. So we need both things. So we need those external artifacts to work with. It is very difficult, if not even impossible, to have intersubjective science of mathematics without these artifacts. But these artifacts become at some point internalized, so you could play with them in your mind, but of course it is useful to have at least a wax tablet or a piece of paper to play with. Then it becomes much easier to work with geometry. That is important. Now, what's the lesson here? The lesson here is that understanding of geometry, and I mean primary school geometry that every school kid on earth probably learns, cannot be reduced to mere external artifacts nor to individual core cognition. It is neither purely internal manner or purely external. It is not just social. If it were just social, we would need to understand why you cannot teach other apes to do geometry, to do proofs. You cannot. You need language as well. So it relies on language. So you need some individual machinery for this. But individual machinery, including our core geometric cognition, as studied by Lee Spelke, is required to do geometrical proofs. So what is the role of these artifacts? I think they co-constitute intertwined distributed cognitive mechanisms, which includes recruitment of older neurocognitive machinery for new tasks. But that also means that it creates loopy representational structures rather than any triumphant cascade. Why is that loopy? Well, one reason is simple. First of all, you internalize external language from external instruction. That becomes part of your inner speech. But then you internalize also pictures, triangles, circles, and so on. You link those together, you internalize them as well, but you cannot really, for obvious reasons, for obvious limitations of your working memory and so on, you cannot work with them totally in your mind. So you need to externalize those things. So you get through external vehicles to internal vehicles and back and forth, but these are not mere operators on mental representations that operate just on our mental contents, because our mental contents is not entirely in our heads. If you go with the proof, it's partially on paper, it's not entirely here. Without some complex proofs are just impossible to have without lots of things going on together. And that lesson generalizes to traditional maritime navigation, to lots of distributed cognitive phenomena. You need more than your mental content or mental machinery of a single person. A single person may not be even in charge. So the agent is the wrong place to look for the basics. The basic unit is a cognitive system, which is a collection of distributed mechanisms intertwined, working together, sometimes in an ephemeral fashion. Still, if that's a representational system, you will have error correcting procedures. Sometimes there will be suprapersonal, so you will have an external teacher that gives you a signal that you have made an error and you have to correct it. Let me summarize. I have gone through a talk that is an extended comment on interactivist model of representation, but it's not limited to that. I wanted to show that there is a role for semantic information as a necessary feature of representational mechanisms. I wanted to also show that representational mechanisms are required for any complex adaptive control of behavior, but they are not necessarily agent-bound. That distributed cognition forces us to think that the kind of function that we're interested in is inherently social in many cases. So they open up a space for distributed cognitive mechanisms. And I think that this vision is very close to the interactivist model of representation. It is heavily inspired by that, but I think that model requires an update because far from equilibrium, thermodynamic equilibrium states of an agent are not the only thing that we care about when we talk about representation. We want to have multiple other things going on, but these are not simply, they do not come in cake-like layers or levels. They become entangled in webs of presuppositions that disallow a simple biological understanding of the overall structure. In broad strokes, however, I would say that with this liberal account, a lot of work in interactivism counts as presenting us with some versions of representational mechanisms. So this work is presented here in ecumenical fashion rather than as something like an alternative. I believe that this work that Mark Burkhardt has developed with his collaborators over the years is extremely inspiring, much more than the traditional analytic philosophy has been for developing the account of mental contents, and that requires a lot of further debate to develop it fully to accommodate new and interesting cognitive phenomena. Thank you for your attention, and see you at the panel.